Hi, software engineers. We're going to finish our journey talking about modern web applications today. But first, let's just make sure we all know where we are and do a quick review. All right, so client server. This is the idea of the separation of where does the processing take place? How much of it takes place in the cloud or on some other machine? How much of it takes place on the client, on the thing that the user is using? So remember that the idea of a thick client means that more of the processing is done on the client side versus the server side. So this would be something like your favorite online video game. I already got a shout out for Genshin Impact from chat. So that one, or Hearthstone, or World of Warcraft, or I'm in just Blizzard property. Well, not the first one, but you get the idea. Microsoft Word would be a thick client. Something that you install locally that needs the internet to do some things, but isn't reliant on it. A thin client means most of the processing is server side, and all of the user interface stuff is still client side, but there's not as much stuff that has to be there. So these are things that really rely on being online always. So many mobile apps are this way. Things like Facebook. Your project is a thin client because all of the processing is taking place on Heroku servers, not on the local machine that is running it, which is a benefit in some ways because anyone can log in from any machine and get the same experience. So that's cool. So client server. 3-tier, the separation of concerns, really the idea of separating data from presentation from business logic. And we see the notion of 3-tier all over the place in computing where we split out these things. It could be how we split out our servers, but we also see it low level in the code. Model view controller is an instance of a 3-tier architecture because the model, the view, and the controller is the data, the presentation, and the business logic. It's just in model view controller, we have more rules around it, I suppose, to really lay out what's the role of the controller and how does it talk to the model and the view. So we have examples of model view controller that you are currently using. Django, which is a model view controller framework, an instantiation of the MVC pattern in such a way that you as a developer can take that code and then build upon it. We would usually just call a framework. So Django, Cake PHP, Ruby on Rails. There's plenty of other frameworks out there. You'll learn that when you're doing the guided practice this week. But we see the MVC pattern all the time in the web and also all the time in mobile, because that's just the way that those systems are architected. And then we talked about REST, representation state transfer, which is an architectural design pattern that tries to fix people from breaking the internet in weird ways. Because when people started programming applications to run on the internet, they started programming them as if they were doing desktop applications. Now, that's fine because that's kind of what people knew, and they were trying to translate that mental model into something, well, that honestly didn't want to use that mental model because of the asynchronous nature of the internet. So, because the internet works on a request response mechanism, that's just the way networking traffic is going to work in this instance. TCP networking traffic, not streaming networking traffic. We want to be able to send a request that has all the information in it so that no matter what server on the server side grabs it in that client server architecture, no matter what server grabs it, that's the controller in that 3-tier model view controller architecture. Hopefully you see how these things are going together now. It doesn't matter which server picks it up. So in Heroku, this is manifested by us increasing the number of dynos, which means that you have more servers available to handle more traffic. That's a good thing. State is allowed to be stored on a database. So behind the controllers in the model, REST says you can expand that database as much as possible. You can have redundancy there, and as many of the servers, the application servers, can talk to that database model, and it doesn't really matter because the database knows how to handle that sort of thing. Whereas application servers might not be able to instantly handle more traffic. So REST, statelessness, idempotency, addressable resources, well-defined operations, and well-structured data, those 5 aspects of REST, very important for making sure modern web applications work. Okay, now, we are coming to the notion of a REST API, all right? You've probably heard of this before. You've probably seen plenty of examples of it. So for instance, we could look at the REST API at Twitter. So for instance, this is the REST API for getting tweets from a particular user. This is the update. So we'll talk about what this means in just a second. So when we say something has a REST API, we tend to mean that it is machine readable. Number one, it's machine readable. So that means that the output is not HTML. Okay, yes, HTML is machine readable, but HTML is meant for people to look at. Whereas if we're sending it to another program, you don't want to parse all that HTML. You don't need to know whether something is a strong tag or an emphasis tag or something like that. So we want to send something like JSON or XML, just the data and any metadata that has to go around it. So while XML or JSON, you can read it, it's not the easiest thing to read. So we don't necessarily care about that. This is data meant for data's sake for other applications to use. Now, when you start making these requests, you can dynamically change that URL by having a different path or passing different parameters to get different data out. So it allows one web application to access the functionality and data of another web application, which is super cool. This is how we get these really big applications that do interesting things with a bunch of different services. So MVC and REST just goes together. If you're building something that's client server and you're using an MVC framework and you're being RESTful, then you probably are going to get a REST API almost for free. And honestly, for your projects, if you wanted to do this, it's not hard. You just change out your template for something that instead of outputting HTML is outputting JSON or XML. And that's just a matter of just changing your for loops to, instead of spitting out HTML tags, they spit out semicolons and curly braces. It's not hard. That's what we mean by swapping out the V in MVC. The model and the controller part, when we are creating this API, stay the same, which is, you're getting two applications in one. Yes. We're just changing out that view to make it work the way that we want to. So let's look at an example. This is a RESTful API that I made as an example a long, long time ago. The data here is very old. This is like when I was still teaching 11.10. So yeah, just roll with it. So let me jump over to Chrome and go to here. And I'm gonna put in that first URL, which looks like this, and that looks like garbage. So let me open it in source mode. Takes a second to load all that data again. But what you can see here is that this is actually outputting a very, well, it's supposed to be a human readable version of a JSON object, which is ugly. And there you go. That's what it looks like. This is written in Cake PHP. And there's a function in Cake PHP, print_r, which lets you just print data in a human readable format. So this is printing an array, and this is a big old array, but we can see all the data that's in here. So let's actually now switch this to view CS. Now, let's again view source on this. There we go. Okay, so this is semicolon separated because I wrote this for an 11.10 assignment in the long ago in the way back time where we wanted them to read data. You might have done this when you were at 11.10 or something very similar to it. But what I did was I wrote code that parsed all the data out of lose list and put it into my own database. And then I wrote a RESTful API on top of it, top of my database for students to read this. So what do we have here? Well, it is straight up like if you were in 11.10, you were writing a program, remember the lesson, how do you read a file? Those lessons where you read a string, split on commas, put in, that's what we were doing. And you could do that here. Now I actually wrote something which I think is kind of cool here at the end. I could put $XML and it gives it to you in XML, or you could do $JSON and it gives you to in JSON, which I thought that was kind of cool. But something like JSON, most programming languages now just have a read JSON. So you import a JSON object and it just does it and just makes the data object in your program that you can just use it, which is, I keep saying it, but this is the stuff that really gets me excited about doing software engineering and architecture, because when all these components fit together, this is really neat. So let's look at some other examples. Here's a great one from DevHub at UVA. So let's go over to that link. So this is the REST API for stuff at UVA. And there's students that work on this. I've had students in this class who were working on this at the time. I don't know if I have any this semester or not, but this is super cool. So look at this right here. So I'm looking at the available API. I'm looking at the facilities. This is the link, API DevHub virginia.edu/v1. So that would be the version of the API /facilities. Now, this is the URL. This is a parameter. The v1 is a parameter. And the facilities is a parameter as well, telling it what sort of data to pull. So I'm actually going to jump over to here. Now I'm going to just do this in command line. Let me click the right windows. All right. So I'm going to go into Python, and I'm going to type import requests. So that loads a library. Import JSON. Now I'm lazy. I'm just going to copy paste the rest of it. Okay, so data equals requests.get. So requests is a HTTP library in Python. You're not going to use this. There's other JSON and API libraries, but this just shows you what's happening. So it says go to this URL.json. So this is just going to take the output and JSONify it, and then or say that it's JSON and print the data. So cool! We have all the information about all these buildings on grounds. I don't know if this is something that you need for your app or not, but if you do, it's just here. Oh, that's so neat. All right, let's go back over to Twitter. So there's a chance maybe you want to use Twitter. Now, I can't just copy paste this right now because you have to sign up for an API key. That's something you'll find when you look at, for instance, that, or maybe Google Directions. You don't want to write your own directions library. That's silly. We want to use Google stuff. That's where it's at. You don't want to necessarily do a cool image gallery on your own. You want to use Imgur. You want to go find these other applications that expose this functionality so you don't have to write it. This is how we go from building software, from writing all the little code bits, to taking these giant Lego bricks of functionality and slamming them together until we make something cool. It's neat. It is so neat. And we want you to look at these things and learn how to import these sorts of things into your own project. All right. So, like, what else could we do? So one thing that we floated to some people is maybe you want to do payment. So Square, the white Square buy all your stuff, when we went in stores, buy all your stuff sort of Square payment system, they have their own API, and they have written their own JSON API libraries that you can use with other applications. REST API libraries for Python that just do all this stuff. PayPal is another one that you can go and look at if you want to do some payment testing out. But basically, any functionality that you want to do that you don't want to program, you might be able to find some system that exposes that functionality for you. Like login. We didn't want you to have to write login. I promise you, you don't want to have to write login, dealing with forgotten passwords, or when do you lock them out, or how do you manage incorrect password. I mean, there's so many functional requirements and non-functional requirements in login that it's often not worth it. Now, Django does have a built-in login model that you could use, but we wanted you to use something that already existed, like Google, which is a way that you're importing their functionality. And this is called using web services. So a web application that provides an interface, a web service, accessible by the internet, provides some function, can dynamically discovered and used. These are called web services. And this allows developers to focus on your core functionality, the thing that you're trying to sell, the thing that you are adding value to, and you bring in the best of everything else to put together an awesome program. I know you've probably used a website and thought, oh my gosh, this would be so much better if it had Dropbox integration, so I wouldn't have to copy and paste things back and forth. Oh my gosh, this would be so much better if it let me log in with Google or Facebook or Twitter or GitHub or any of the other login providers. There's a reason that we like these things. They provide value to our users. Now, think about the extreme here. What if we literally built our entire application from just snapping things together? like a food ordering web application. So you can have Imgur to store the pictures, Square to take payments, Google Maps for directions, use Facebook for login. Wow, you don't have to write a ton here. I mean, there's some, but certainly not a ton. But what are the trade-offs? I want you to take 2 seconds to think about what's a problem with doing this. What happens if Imgur goes away? What happens if Square goes away? What happens if Facebook takes over the world and eats your code and then okay, never. But you get the point. You're now reliant on other services. Is that good or is that bad? I mean, we kind of all scratch each other's back now if you look at kind of the way that the internet is kind of built. So in many ways, it's probably safe, but it is something you have to think about. And whenever there are updates to those applications, you need to stay on top of them. Here's an example from Microsoft of how some of this might work. So for instance, you have a gateway app in a backend that is managing your mobile app and your web app, or some sort of client app that's in a special environment. But then your traditional web app is going to its own set of templates, its own set of views and an MVC framework. And then that gateway knows how to talk to each of those web services to put together the full app itself. The full extreme of this we would call a service-oriented architecture. Yes, coming from the term web service. Web services weren't always done with REST and JSON and that sort of thing. The original version of REST came from something called SOAP, the Simple Object Access Protocol, I think. SOAP was really around the idea of remote function calls, and you would write basically a Java function that then you could expose that functionality through a port that could be dynamically accessed by other applications. But the reason that we like a service-oriented architecture is that it really focuses around business objectives. So if you were structuring an ordering system in an object-oriented architecture, you might have, well, think about it. What might you have? What objects would you have? Messing up my green screen. You might have product, you might have order, you might have customer, you might have all of those individual things. Now, and then each of those might have something like process payment or whatever. Now, where do those live? I mean, in a traditional architecture, that's very centralized. That might not be what you want. Maybe you want the warehousing group to have their own application that manages inventory. Order management has their own application that manages orders and customers. You might want these broken out. It's very common for programmers to think about software as being a collection of, well, here are the nouns and here are the verbs. And that's fine. That's the way we taught you back in 2110, back in, early in your earlier programming, because that's how you learn Java, object-oriented development. But what if you thought about a program as a set of functionalities, not as a set of objects? Excuse me. Now, if we did this in our example, we might have an order management object or entity, customer service entity, a warehouse entity, a shipping, a billing, and it could look something like this. I'll come back to the previous slide in a second. I just wanted to show this. So this would be for processing an order. And when you look at this, an order comes in, you receive the purchase order, you're getting items of inventory, compute the subtotal. Now, each of these would be an exposed service from the different parts of your organization. What this allows you to do is to dynamically put together business objectives, business logic from functionality components exposed by the different parts of your business. This is one of the reasons that Microsoft and things like .NET became very, very popular in the 90s and 2000s, because the whole idea of that programming infrastructure was you built these DLLs, dynamic link libraries, that had functionality that exposed certain aspects of the core business of the organization, and you built new applications for the business by basically taking these functionalities and chaining them together like this in a business procedure. What was the benefit of doing this? Well, you didn't have to relearn what a customer was or what an order was or anything like that. You just had to pick up the right functionality block and know what the input and output was. So if for some reason something changed with the business model of the company, you could pivot your software to do something new lightning fast. This was very beneficial at the time. Still is beneficial. Matter of fact, some businesses still, this is the way some software companies, this is the type of software they sell. Appian is probably one of the best known ones right now because they build, their package is all about building the business functionality around existing units. So if each business unit exposes their own functionality as a web service of some kind, then inside your organization, you can construct your own internal application relatively quickly. Now, the user interface might not be great because that's harder to just reuse, but you could actually get something new going pretty quickly. So in larger organizations, the idea of building a service-oriented architecture for internal to a company makes a lot of sense. Each unit exposes their functionality, you build off their APIs, and then eventually you can roll out new software. Now, that's the extreme. What we see with web services, with projects like yours, is, hey, I would really like to have payments. I would really like to have someone else handle login. I would really like to have someone else handle image storage and manipulation. You know what? There's a web service for that, and you can find it, and then you can utilize it. Now, you might be wondering, how do people make money off these things? Well, there's a way of making money off of almost anything on the internet. So here, the way it works is this. Whenever you sign up for an API key with these services, it's typically something like the first 10,000 transactions a day are free. And you might think, wow, that covers everything. And yeah, for hobbyists or something very simple, they want people to learn their tools and to feel good about them. So when they go off and work for a company and they want to keep using those tools, and now they're processing millions of records a day, the company makes a little bit off of each transaction. That's how Google makes money off of their directions and their API, and that's how Twitter can make money. As all these companies can make money this way. I mean, advertising is still very large, but this is still something that you can charge for. Funny story. We were using the Google Maps API in 11.10 when we were talking about consuming this sort of data, and I wrote a lab where the students had to figure out some directions to the nearest Wendy's or something like that, I think. And I used my own API key. This was early on, before I knew better, and put it in everyone's code. And after the first lab, after about 30 minutes of the lab, the TAs were calling me, telling me, hey, everyone's code isn't working. Something went wrong. Well, what went wrong was a CS 1110 student put their API call in an infinite loop and used up all of my transactions for the day in about a second and a half. Lesson learned. So there you go. I hope this helps you understand how we build modern web applications and what it means to build a web service and to have a REST API, because, man, we can do some cool stuff with it. So for your guided practice, you're going to be looking at how some of these frameworks work. Have a great one. Thanks for hanging out.